Around 66 million years ago, a massive asteroid smashed onto our planet Earth, putting an end to the 180 million year long reign of the dinosaurs. Upon impact, this asteroid obliterated everything in its path and triggered a chain reaction that killed off most life on Earth, hastening the end to the Mesozoic era. Because the asteroid melted the crust and mantle at the point of impact, it took at least 30,000 years for Earth to recover from the destruction caused by the crash. Surprisingly though, even at ground zero, life rebounded quite rapidly and closely mirrored the comeback of life everywhere on the globe. Within 300,000 years, productive ecosystems started to form all over the world, and evolution filled almost all the empty environmental niches on Earth's 10 million years later. But what most people don't know is the immediate impact of this collision and its aftermath in the first few minutes after dinosaurs disappeared. Today, we're going to visit a planet where humans haven't yet set foot, a planet that was nearly obliterated by a meteor. You'll learn which ancient occupants of the world died immediately, who survived, what climate changes they had to deal with, and how the Earth was recovering from a massive calamity. So without further delay, let's jump straight in the video. What happened when a giant asteroid crashed into and transformed the planet? Imagine the sunrise 66 million years ago, on the final day of the Mesozoic era. Along the coast of what is now Mexico's Yucatan Peninsula, shafts of sunlight rake through the swamps and coniferous forests. The Gulf of Mexico's waters are so warm they're practically a bloodbath, and they're teeming with life. A mountain-sized asteroid is hurtling towards Earth at about 40,000 miles, or 64,000 kilometers per hour, as this long-lost world of dinosaurs and enormous insects squawks, buzzes, and whirs to life. It lasts only a few seconds, but during that time, a fireball seemingly larger and brighter than the sun rips through the sky. Afterwards, the asteroid crashes into our planet with an explosive yield of over 100 trillion tons of TNT. The impact vaporizes thousands of cubic miles of rock and creates a crater more than 115 miles across and several miles deep into the Earth's crust. This triggers a series of global disasters that kills off about 80% of life on Earth, including the vast majority of dinosaurs. Since the asteroid impact theory was first proposed in 1980, countless books and magazines have described this end-of-the-world scenario. The Yucatan Peninsula in Mexico is home to the impact site now known as the Chicxulub crater. It is estimated that the asteroid's width was about 10 to 15 kilometers, but the impact caused a crater on Earth with a diameter of about 150 kilometers due to the high speed at which it entered the atmosphere. There were widespread tidal waves and significant fires as a result of the impact, which sent debris flying into the atmosphere. Aside from the immediate destruction, the asteroid also caused some lasting changes. By separating from one another, the continents altered the circulation of the oceans and the composition of the atmosphere. The rise in volcanic activity also contributed to the alteration of global climate by releasing gases into the air. The exact mechanism by which the fallout exterminated so much terrestrial life, however, remains a tantalizing enigma. On a drilling platform in the Gulf of New Mexico, a group of British scientists have recently collected the first core samples ever taken from the Chicxulub crater peak ring. Immediately after the impact, the Earth's shock caused it to rebound, and the resultant swelling created a large circular structure within the crater's walls, which is where the ring can be found. Experts hope to learn more about the phenomenal forces at play that day by studying the upside-down geology of the area. Reliving catastrophe. The imaginations of Hollywood scriptwriters would be utterly limited by what is already known. A group of geophysicists from Purdue University and Imperial College London created an impact calculator that allows us to enter key details, such as the size and speed of the asteroid, to generate a detailed simulation. Inputting different distances from the point of impact allows you to observe how the effects evolve with distance. The fireball would kill anyone within a few seconds if they were within 100 kilometers, or 625 miles of it. Really, if you could see it, you were already dead. Anyone observing the impact from that far away, 9 seconds later, would have been blasted by a wave of heat. All the plants around you would have spontaneously combusted, leaving you with a third-degree burn all over your body in an instant. Unfortunately, the flood follows the fire. A phenomenal tsunami as high as 1,000 feet could have been generated by the impact. Depending on the local topography, even if the resulting earthquake was only 10.1 on the Richter scale, it would have been the strongest ever recorded or felt by humans. This magnitude of earthquake would be the same as if every earthquake in the world in the past 160 years occurred at the same time. Around 8 minutes after impact, ejecta would begin to rain down, covering the ablaze landscapes in a thick layer of hot grit and ash. The ground would be buried under hundreds, perhaps thousands of feet of rubble near the impact zone. In another 45 minutes, a windstorm with gusts of up to 600 miles per hour will rip through the area, scattering debris and flattening any buildings that have not already fallen. The blast's ear-splitting roar, measuring in at 105 decibels, would also arrive simultaneously. Outside the blast's immediate area of effect, observers would be treated to a dramatic darkening of the sky and an apocalyptic display of shooting stars as impact debris rains back to Earth. They probably didn't look like meteors or shooting stars. As they accelerate, meteors heat up and eventually burn out. Infrared radiation would have been emitted as these re-entered the atmosphere at low altitudes and slowed down. Eventually, the sky would grow dark after the red glow faded because of the ash and debris that circled the globe. There would have been very little light for the first few hours, but then the clouds would start to break up and the sun would come out. The days, months, and maybe even years that followed were probably somewhere between dusk and a very overcast sky. End times. Although the impact itself and the immediate minutes to days after it are what most people remember, it was the long-term environmental effects that killed off the dinosaurs and much of the rest of the planet's life. Due to the dust cloud's general dimness, photosynthesis would have been severely stunted. It would have taken months for the soot and ash to be washed out of the atmosphere, and by the time it did, the rain would have turned to acidic mud. The planet's protective ozone layer may have been temporarily depleted due to the massive amounts of toxins produced by the fires. Then there was the impact itself, which is thought to have released 10,000 billion tons of carbon dioxide, 100 billion tons of carbon monoxide, and 100 billion tons of methane all at once. A powerful 1-2 punch of nuclear winter and dramatic global warming likely followed the asteroid's impact, and that is where the newly extracted core samples from Chicxulub crater come in to help fill in the blanks of this infamous tale. A gradual transformation. After the dinosaurs died out, flowering plants took over, continuing a trend that had begun in the Cretaceous epoch when all land animals weighing in over more than 25 kilograms per person per year were wiped out. What remains are the germinal elements of modern society. Almost every major group of animals that ever lived before the asteroid impact is now extinct, but the genetic material that eventually gave rise to today's animals was able to survive. Aside from birds, all dinosaurs became extinct. Some bird species did become extinct, but the ancestors of today's birds persevered. Large mammals first appeared during the Oligocene epoch of the Paleogene period, roughly 15 million years after the extinction of non-avian dinosaurs. Before that point, every available space on Earth had been occupied by a variety of tiny animals. About 3/4 of Earth's plant and animal life, including all non-avian dinosaurs, perished when an asteroid struck the planet. In the period following the Paleogene, called the Neogene, large swaths of forests were converted into grasslands and savanna, creating new food sources and ecological niches that aided the continued evolution of mammals and birds. Also, the variety of marine mammals increased, and the size of sharks increased. Changes in the climate and the breakup of the continents led to new and more complicated patterns of mammalian evolution. The ones who made it out alive. Research into what happened after the dinosaurs died out suggests that it was not a simple case of one set of animals dying out and another setting up shop in their place. Instead, researchers have found that smaller mammals fared better after the crash because they were better able to hide and because of their lifestyles were more flexible. Evolution in mammals proceeded rapidly after the extinction. They predated the dinosaurs by millions of years, but were much smaller back then, about the size of badgers. However, they took advantage of the opportunity and started to evolve really fast. Within a few, in the final 10 million years of the Cretaceous period, flowering plants became more common, marking a change in vegetation, as compared to the previously widespread ferns and conifers. As a result, the environment in which the animals thrived also became more intricate. Among dinosaurs, only birds made it out though. Large reptiles like crocodiles and alligators managed to make it through. Smaller dinosaur relatives such as lizards and snakes also made it through. So, before ending this video, we have a question for you. How long after dinosaurs did humans appear on this planet? Share with us in the comments below. Also, if you like this video, give it a like and share it with your friends so we can keep making videos like this. For more content like this, subscribe to our channel. Also, be sure to check out our other videos as well. Thanks for watching.